I'm going to draw a building. I'm going to draw a flagpole on top of that building. And we are 125 meters from the foot of the building. So here's the foot of the building, 125 meters away is where we're looking. Sort of like, and what this means is if you had a clinometer, you could actually do this. If there was an object on top of an object, we're going to be able to figure out how big that flagpole is this way as well. Pretty cool stuff. The angles of elevation to the top and bottom of the flagpole, here's the top of the flagpole, here's the bottom of the flagpole, are 40 degrees and 37 degrees respectively. Respectively means that the 40 goes with the top, what's listed first goes with what's listed first, and the 37 goes with the bottom. So if I draw a line to the top, I know that this angle of elevation is 40. In a different color, if I draw a line to the bottom, I know that this angle is 37. So this is the diagram that we have to start with. I'm going to ask you, how many triangles do you see? Everybody sees 2 right away. Can you see more? You see more than 2 triangles? Because this is the key to this question, is seeing the third triangle. The whole thing is a triangle. What I'm going to do is I'm going to draw one triangle, this small triangle. Everybody saw the small triangle at the beginning, right? I'll draw that one in blue. I'll take it, I'll drag it over here. I'll label what we know. We know that this is a right angle triangle in the blue one. We knew this was 125. And we knew that this angle in the blue one was 37 degrees. The second triangle that everybody sees is this one, right? I'm going to draw this one over here. What do you know about this triangle? It's not a right angle triangle, so we can't use any trig that we've learned. Can't use SOHCAHTOA for that. Can't use a squared plus b squared equals c squared. The angles will still add up to 180, but that's the only thing that we can use in this triangle. Do we know any angles in that triangle?
Oh no, it wouldn't be 40, it would be...
Yes, 3 degrees.
Oh yeah, the difference between...
The 40 and the 37. Good. And finally, the hardest triangle to see, and I'll do it in black here. And in the black triangle, we know this is still 125, and we know that this angle is 40 degrees. What are we trying to find? We've drawn our diagram. Find the height of the building. So I'm going to call that x. And the height of the flagpole, I'm going to call that y. Those are the 2 things we need to solve for. On our diagrams, can you see that on our blue triangle, we can put x here? On our black triangle, this isn't y. That's the whole thing. That's going to be from here down to there. What would you like to call that? A. So A over here is the same as x plus y.
Why?
X plus y makes the whole thing.
Oh no, I was saying y. I was like, yeah,
Oh,
y.
y, does it equal it? Oh, okay, I get it. Let's go to our triangles. On the blue triangle, can you solve for x? Do we have enough information? Do we need 3 pieces of information, at least one side? We do. So on the blue one, SOHCAHTOA. Which one? We want to find x. With that 37, the x is which side? No, opposite, because it's opposite the 37. The 125 will be adjacent. SOHCAHTOA, which one would you use? Sine, cos, or tan? Tan. So we write tan of 37 equals opposite is x, adjacent is 125. Multiply both sides by 125. $125 tan 37. X is approximately 94.19 dot dot dot. I'm going to store that as x. So I hit my store button. You can either go alpha x, or the shortcut for x is right here. Push that button. That'll store it as x. Now we go back to our screen. On the black triangle, do we have enough information to solve for y? Solve for a? Is there enough information to solve for a? Well, we got 3 pieces of information. We got 3 pieces of information, at least one side. Yes, we can solve for a. If we use the 40 degrees, the a is which side? Opposite. With the 40 degrees, the 125 is adjacent. SOHCAHTOA, tan. Tan of 40 degrees. Opposite is a. Adjacent is 125. Multiply both sides by 125. And we go to our calculator. 125 tan 40. And we get a as 104.8. I'm going to go back to my main diagram and label some of this stuff. I know my x is 94.19, so 94.19 dot dot dot. I know that the whole thing is 104.8. We've already solved for the height of the building. The other thing we wanted to solve for was the height of the flag. Do we have enough information now? So y is going to equal the 104.8 minus the 94.19. In order to do this without rounding early, can you see I already have the 104 still in my calculator? So if I hit subtract, it'll automatically take that answer and subtract it. And I stored the 94.19 as x before. Boom, 10.7. Does it ask for a certain amount of decimal places? But it is a word problem, so we need to write it with a sentence at the end. The height of the building is 94.2. Is it meters or feet? Meters, thank you. And the height of the flagpole is 10.7 meters. Circle my final answer. Perfect circle. Nice.